Does everyone have a calculator? I haven't seen that girl in a month. I haven't seen her in a month. No. Mm-mm. Are you sick? Yeah, because you guys got him sick. I didn't get you sick. See, I didn't get her sick. She got. Leilani got me sick. Hey, Leilani, if you're watching this video, thanks for getting everyone sick. All right, here we go. Here we go. What is this guy doing? All right, here we go, guys. This question is from the 2004 ABBC. Why did you put ABBC? The AB exam and the BC exam share 3 common free response questions. So out of the 6, 3 of them are shared by BC. Chop, but why does the BC exam have AB? 60% of the BC exam is AB. So when you get to Cal 2, hopefully in the beginning of the course, will all be review stuff. For the ones that are doing BC, you'll have enough to get rid of Cal 2, the series and sequences and all that good stuff. Which some of you might like series and sequences. Some of you have not done sequences since geometry, so you might not like it. So make sure you cover that before you go to Cal 2. Like at least do a fresh up. And do you guys remember polar? Okay, so make sure the polar. Make sure that you're aware of how to do polar, so you can do the polar integration and all that good stuff. Or just come in. If you're here, look at my videos. I'll be posting some because Dinan is in BC. So as soon as if you follow my channel, we'll do BC videos and just go watch the videos and see if that helps. All right, here we go. You guys ready? Ms. Kyle, would you like to read number 1? Okay.
Traffic flow is defined as the rate at which cars pass through the intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f defined by f of t 82 plus 4 sine t over 2 for t between 0 and 30, where f of t is measured in cars per minute and t is measured in minutes.
Okay, so they really, really care about units because they mentioned it twice. They mentioned it up here. Traffic flow is defined as the rate which cars pass, measured in cars per minute, and then they mention it again, where f of t is measured in cars per minute. So let's see if units have something to do with this here. Letter A, to the nearest whole number, how many cars pass through the intersection over the 30-minute period? Yes, integral. I find these type of questions to be automatic points. Guys, get your points. All you got to do is, so tell me what to do, Henderson. No, you're right. Say it loud and proud. Integral. That's what you said, right? Integral. 0 to 30. And what am I going to integrate? Did they give it a name? F of t dt. It is a calculator section. Do I have to show them how to do the antiderivative? No. I'm going to probably need this equation over and over again. And I know you have Desmos, but for the free response, I actually prefer the calculator because you can manipulate the equation so many ways. And you have the watered down Desmos. So here's my calculator, y equals. Make sure it's in radian mode, so reset it. So how do you reset it? Second memory 712, because the pre-cal class has been doing law of sines, law of cosines, all that good stuff. All right, y equals. What's the equation again? 82 plus what? 4 sine, plus 4 sine. And what do I have on the inside? X over 2. That's it, right? Okay, so I can write it like this. I would probably prefer you use a fraction feature, especially if you have fancy stuff in there, but I don't need it here for this one. And here we go. Math, number 9, from what to what? 0 to 30 of f of t. There it is. I put x and I push enter. Thank you, miss. What am I going to write? I appreciate it. 2474. Did they say anything about rounding? Nearest whole number. So you're going to write 2474 cars. They actually would probably prefer that you write a statement, but this is full credit right here. Do you have to show them how to do the antiderivative? Heck, you don't even have to write the expression. Now, if they were to say y equals whatever, then they probably want you to write the expression, but that's probably the non-calculator where they want you to see the antiderivative and all that. All right, are you guys ready? Letter B. Rodriguez, do you want to read this one for us, please?
traffic flow increasing or decreasing at t equals 7? Give a reason for your answer.
Okay, before we do anything, a lot of kids get confused and they're like, oh, does that mean f of 7? Does that mean f prime of 7? I don't know. Guys, if you're having a hard time deciding between which one, then give this a name. Don't call it traffic flow. What do you want to call this? Oh, I was going to say give it a name. Call it what? F. Yeah, that's f of t. Yeah, little f of t, big f of t, whatever. And then anytime you come across that word, traffic flow, don't say the word traffic flow, say, so it says, so look, is I guess erase the, is f of t, or f of whatever, increasing or decreasing at t equals 7? Give a reason for your answer. How do I figure out if f is increasing or decreasing? If f prime is positive, f is increasing, and if f prime is negative, f is, there it is. So all I got to do is go derivative, and do I got to show them how I got my derivative? No, you just got to show the setup. Go f prime of what value? 7, and then give me the answer. Do I already have f in the calculator? So just go math, number 8, put an x here, put alpha trace y1, there it is, that's derivative at x equals negative 1.8729. Negative 1.8729. So what's happening to traffic flow? And it says give a reason. So all you got to do is say traffic flow is decreasing, and you got to tell it at what time? At t equals 7, since f prime, notice that I put capital F prime. Capital F prime of 7 is negative. Well, actually, you don't have to say at t equals 7 because you're already saying it with the expression, with the 7 in there. And there it is, full credit. How do we feel? Okay. You know how usually I say at t equals 7 like I did here? I don't have to say it because I said it f prime. But if you didn't put the 7, let's say I would have said this. F prime of t is less than 0. You better put at t equals 7. Because, yeah, we're talking about derivative at a moment, at a specific moment. The best answer is probably just putting in the 7 in there. F prime of 7. Cool or not cool? Well, we make sure f of t is less than 0 at t equals 7. Like, you got to, you know what I mean? Because we're talking about a moment, at that moment. We're good?
No, yeah, I was just saying I put both.
I would just put this one. You okay, Rodriguez? Okay. I know we're tired, guys. Don't worry, that's why we're only doing one. And look at this one. Ready, Vega? Huh? I think it's easy because we just did average everything yesterday. It wasn't the average score on this was not like a super high one, but we just did average everything yesterday. So look what it says, letter C. What is the average value of the traffic flow? We gave traffic flow a name. What do we call it? F. So what is the average value of F, capital F if you want to call it capital F since that is the name of it, over the time interval 10 to 15, indicate units of measure. What am I going to use, Vega? Yeah, so tell me. 1 over 15 minus 10 integral of what? FT. TT. Do you guys like this play on words? Or, I mean, I guess you could have just given it the name or whatever. All right. Do you have to show anything? No, this is my setup. This is a setup. And notice, look, they're making it a big deal. Indicates units of measure. That's why they kept telling you about it. All right, first let's do that. So I'm going to go alpha y equals 1 over 5. Because that's what, or I guess you can put, that's what, 15 minus 10. I'm not insulting your intelligence, guys, I promise. Math 9, lower limit 10, upper limit 15. And do I have f of t in my calculator? I have it saved as y1, so here it is. And x. Answer. How many digits do I need? Because this time doesn't say whole numbers. At least 3. The more the better. 81 point. And now it says indicate units of measure. All right. Hold on. Relax. Hold your horses. This that I put in brackets is in cars. Because remember, f of t was cars per minute, right? Cars per minute times minutes is cars. And then the 15 minus 10 that's in the bottom here, that's minutes. So this is going to be cars per minute. Yeah, it has to be the same. It has to be the same units as whatever f of t is because this is an average value of f of traffic flow. Does that make sense? Okay. Are we still okay? Okay. Letter D is the one that a lot of kids find hard. I think that's probably the one that a lot of kids miss points in, but not you guys because we did that circuit yesterday. And we're gonna do that hack. What is the average rate of change of the traffic flow over the time interval 10 to 15 indicated in the manner? You probably got it already down, but remember if you're having a hard time, call traffic flow F and what underline or put this in brackets, rate of change. What does rate of change mean? Well, yeah, rate which but usually like sometimes we say instantaneous rate of change. So if I say rate of change, that means F prime. So maybe erase this right here. What is average F prime? Yeah, okay. I know. I hope I'm not confusing you. You're gonna get there anyway. See, you probably would have just done it without the integral. What I'm trying to say, guys, is this: if you wanted to use the average formula, you could still do it. This is like average f prime, right? Don't write this down. Just listen. So take this in. So you could have gone 1 over 15 minus 10 integral 10 of 15. Don't write this down. Just listen. F prime of t dt. That would have given me the same thing. Vega wanted to go right into it. Vega was like f of b minus f of a. Look, it would have worked. F of 15 minus f of 10, because in Vega's mind, she already did average everything, and she's like, I already know average over. No, it's the same thing. Notice, look. What times I derivative of f prime? F. I would have done the same thing anyways. If you would have done the play on words, then you would have been like, oh, rate of change f prime. What is average f prime? Well, I'm just going to do this. Look, you'll get back to this anyways. Isn't that cool? So I'm just trying to give you guys strategies in case you read something and you're like, oh, I don't know which one to use. So I'm trying to give you guys strategies that it doesn't matter what you do. If you understand what's going on, you're going to get it right no matter what. I don't know. Should I even mention this? I don't know. Okay. Because I know a lot of you will probably do that. But look, as long as you know what you're looking for and you know, like, rate of change, that's like f prime. What is average f prime? Oh, boom. You're going to get that anyways. Is that cool or not cool? All right. What is f? Okay. You don't have. This is called a setup. Either one of those will work. But if you put this one, I would like for you to eventually put that in there. So then I'm going to write f of 15 minus f of 10 over 5. All right, here we go. I take my calculator. This is called a setup. I'm going to push a little fraction feature. And I'm going to go alpha trace open, y1, 15. Chop, what are you doing? Well, I have f in y1, right? Minus alpha trace y1 again. What was it? Was it 10? And then close that. And then I'm going to divide by 5. Bam. 1.517539. I already forgot. 517539. And now look, again, indicate units of measure. This one's a big deal about units. The top has units cars per minute. The bottom was 15 minus 10, which was minutes. So you can either say cars per minute, or you could say cars per minute squared. If you're a physicist, you will probably like the cars per minute squared. I've never been a fan of that. I think it's better. Like, what does cars per minute squared even mean? I like the cars per minute because I can see what, like, oh, that's how many cars per minute went in that minute. It's the rate of the rate. Okay, what's up?
Can we equal this setup on the right to this one over here? The complete.
I would have done from here to here. Like, I want to show that. Because you want to go from here to right off the bat to that number. You might be okay, but I wasn't there when we did this rubric. This from what 2004. I was still in college, okay. So I don't know. I wasn't there when they graded this. So this is the better one. But I just showed this f prime to show you that it doesn't matter how you do it, that you'll get the same answer. All right. Do you want to pass the rubric, Rodriguez? Let's see how we did. I was looking at the rubrics because I had to make a copy of it, but I didn't analyze it. Like, I didn't stare at it. Every free response is worth how many points? How many points are you shooting for every time you do this? At least, yeah, at 4 or 5 at least. At least. If you get 4 or 5 points every time, you're in the hunt. If you get 6, 7,
6, 7.
If you get 6 points, you're looking like a 4. And if you get more than 7, then you're in real good company. Look at this. I am so shocked. I am, because I wasn't studying this rubric earlier this morning. I'm shocked. I am shocked. Look how many points they made letter A. Can you get at least 3 points in this free response? They give you one. Wow, they're being so generous. 1 point for the limits, 0 to 30. 1 point for the integrand, that's that integral of f of t. And 1 point for the answer. Can everyone in this room get 3 points? Yes. Look at letter B. Answer with reason. F prime of 7 is negative. Since f prime is negative, the traffic flow is decreasing at t equals 7. Everyone's going to look exactly this, well, more or less, hopefully the same. Are we still okay? Look at letter C. Again, I think they're being very generous. How many points? 3. 1 point for the limits, 1 point for the integrand with the 1/5 on the outside, and 1 point for the answer. Letter D, 1 point. And then 1 more point for the units on C and D, and we got the units on C and D. Did we get the units right? Cars per minute and cars per minute. They wrote cars per minute squared. Lame. Cars per minute I think is better, but they're both mean the same thing. Are we getting confident? Do we understand what we're doing, guys? Did this help? For sure. 100%. 100%. All right, guys, you have an hour. I really want you guys to work on your stuff. So please work on calculus, and we'll call it a day.